Okay, problem number 5. This one is a big, messy problem. I hope I have enough room here. So, looking at this one I actually have two things being multiplied together. So, this is a u times a v. So, my u is going to be equal to 2 minus 3x squared to the third power. And now that, I'm going to have to use the chain rule to do that one. Horrors. Okay, so I'd have to do like u substitution again. So let's call that, I don't know, w substitution. So I'm going to w be 2 minus 3x squared. And so then u is equal to w cubed. So I have to do the chain rule to get the derivative of u, and then I'm going to have to do the chain rule again to get the derivative of v, and then I get to do my crisscross applesauce business. All right, so the derivative of w, okay, that's a constant, it goes away, so that'd be negative 6x. The derivative of this one over here would be 3w squared. So the derivative of my original function here would be negative 6x times 3w squared. I'm going to go ahead and substitute back in for my w because I'm going to run out of space here. So my w, this guy right here, I'm going to substitute this back in already. 2 minus 3x squared, and that is squared. Bam. Okay, now that's just the first part, right? Here's u prime. Now I need to do the same thing for v. So v is equal to 2x squared minus x plus 1 squared. So to take the derivative of this, I'm going to need the chain rule again. I'm going to go ahead and use w for this one also. W is going to be this inside part. That's like my u substitution. So the derivative of that would be 4x minus 1. Now if I rewrite this with w, I get v is equal to w squared, okay, because all of this is w squared, and the derivative of that would be 2w. So I'm using the chain rule on this, so the derivative of this is this times this. So v prime is going to be equal to 4x minus 1 times 2 times w. Well, w is all of this, so let's go ahead and put that back in. 2x squared minus x plus 1. Holy cow. All right, now, because it's the product rule, I'm going to have to crisscross applesauce, this one times that one, and that one times this one. It's going to be a humongous mess. Let's get started. So, doesn't really matter which one I do first, because it's the product rule, so I'm going to be adding. I'm going to go ahead and start here. So my dy dx, my final derivative here, is 2 minus 3x squared to the third times the derivative of the second part, which would be 4x minus 1, parentheses 2, parentheses, 2x squared minus x plus 1. Okay, plus the other side, which would be 2x squared minus x plus 1 squared, all of that, times all of this, so times negative 6x times 3 times 2 minus 3x squared squared. Holy cow, so there's the derivative of that giant mess. Now it wants me to say, what is the slope of the tangent at x equals 1? Well, this is the gradient function. This will get me the slope at the point on the graph where x equals 1. So all I have to do is plug in 1 everywhere I see an x. Yeah, sounds easy. Except that this is such a mess. But it's okay, we can do it right now. I mean, it is possible to simplify this a little bit, but I think it's more hassle than it's worth. So I'm just going to go ahead and change all the x's to 1s. So I have 2 minus 3 times 1 squared cubed times 4 times 1 minus 1, 2 parentheses 2 times 1 squared minus 1 plus 1 plus 2 times 1 squared minus 1 plus 1 squared times negative 6 times 1 times 3 times 2 minus 3 times 1 squared. All right, so all of these calculations are pretty simple. There's no division. There's not even really any negative numbers. The negative numbers are minor. So it would be, I could do this by hand, but I've run out of room. So what I'm going to do now is I'm going to type it all into my calculator. So I'm just going to make sure I use all the parentheses and type it in. 2 minus 3, parentheses, 1, close parentheses, squared, close parentheses, to the third power. Okay, there's that first part. Times parentheses, 4 times 1 minus 1, close parentheses, open parentheses, 2, open parentheses, 2, open parentheses, 1, close parentheses, squared, minus 1 plus 1, close parentheses again. Okay, that should be the first part. Let's go ahead and get that. What the heck? That's negative 12. So this part from here to here, when I substitute in the 1, I got negative 12. So I'm going to write that down. So this would be the derivative at x equals 1. So how do we write that? dy d1? I'm not even sure. Okay, but anyway, it's negative 12, and then I'm going to get the second part. Okay, so parentheses, 2, parentheses, 1, close parentheses, squared, minus 1 plus 1, close parentheses, squared, times negative 6, times 1, well, what the heck, I'll just write it anyway, don't need to, but whatever, times 3, parentheses, 2, minus 3, parentheses, 1, parentheses, squared, close parentheses, squared, and I got 144. And I think I made a mistake somewhere, because that's not the right answer. Uh-oh. Shoot, I made a mistake. Okay, because the answer is actually negative 84. And how do I know it's negative 84 if I can't get it by doing it the long way? I know it's negative 84 because there's actually a shortcut on the calculator. So let me just see if I can do this by hand better. Make sure that I didn't make a mistake. So 3 times negative 6 times 2 minus 3x squared. That one's squared. Okay, I did that right. Over here, 2x minus x plus 1, 4x minus 1. Nope, everything looks good. So let's see. I'm just going to do this in my head, because maybe I didn't enter it into the calculator right. So let's try this again. So 1 squared is 1. 1 times 3 is 3. 2 minus 3 is negative 1. Negative 1 to the third power is negative 1. And then this part right here, 4 times 1 is 4. 4 minus 1 is 3. And then this part right here, 1 squared is 1 times 2 is 2. 2 minus 1 is 1. 1 plus 1 is 2. 2 times 2 is 4. Multiply those together, negative 12. Okay, so that looks good. Now let's see what happened over here. 1 squared is 1. 1 times 2 is 2. 2 minus 1 is 1 plus 1 is 2. 2 squared is 4 times negative 6 times 3 is negative 18 times 1 is negative 18. And then here, 1 squared is 1. 1 times 3 is 3. 2 minus 3 is negative 1. Negative 1 squared is 1. So I have 4 times negative 18. There it is. So that's negative 72. So somehow when I put it all into my calculator, I must have made a mistake somewhere. Because when I did it in my head, more or less, I actually did a better job. Negative 12 plus negative 72 is negative 84. So my derivative was correct. I was just having a little bit of a hard time entering all this into my calculator, which goes to show that my brain is better than my fingers at doing some calculations. All right, so now I mentioned there is actually a shortcut on your calculator. So on your calculator, I'm going to show you right now, if I want to know the slope at this point on this function, all I actually have to do, and I already have it typed in here because I knew I was going to show you this, is I enter in the function and I graph it. So that's what it looks like. Kind of crazy. I could zoom out to see more of it, but I'm not too worried about that because I just want to know what happens when x is 1. When x is 1, what is the slope? Okay, what is the slope? The calculator will calculate it for you. It won't show you the derivative, but it will show you the value of the derivative at a given x value. So the way you do this is you hit second, calculate. Notice that's above the trace button. And notice option number 6, dy dx. That is the derivative. Oh my gosh, it's right here. So press number 6, and then it kind of like makes you go, yeah, and then what? It doesn't tell you what to do. So here's the trick. You just type the number that you want x to be. So I'm just going to hit 1. And notice what happened. It says, oh, you want to know the derivative at x equals 1? And I say yes. And it tells me dy dx is equal to negative 84. And notice it has 0.00302. That's because the calculator is actually calculating the first derivatives principle. It's using that formula. It's not actually doing the entire derivative using the shortcuts like we did. What it's doing is it's taking a point at x equals 1 on the graph, and it's finding another point really, really close to it, and it's actually manually calculating the slope between those 2 points. So it's not doing the same technique that we are doing, that we did on our paper. It's doing a different technique, but because it's such a smarty pants at being able to calculate decimals and stuff like that, it will find the answer for us. So it won't tell us the derivative equation, won't show us the gradient function, but it will tell us a value if we ask it to. Okay, so to show you that one more time, I went second, calculate, number 6, and then at what point, calculate the derivative at what point, you just have to tell it which point, you just press the number. So I press a 1, bam, and then hit enter, and then look for the dy dx, and it gives us the answer. All right, it's a little calculator move, and it matches what I got, even though it took me 2 tries. Okay, that's that.